Okay, so for the following differential equation, uh, we this is actually a homogeneous differential equation. So the way to solve this is going to be quite different. So to check if it's homogeneous, let's factor out x squared. So this is 1 plus y squared over x squared d of x plus x squared 1 minus y over x. And we see these are to the power of 2. Sorry, yeah, see how these two x's are to the power of 2? So they have the same power or degree. So this is how you know that it's a homogeneous differential equation. So pretty much this is how we're going to start. So let's revert this back to its original equation. We're going to have y equal to u of x, okay? Or w of x or whatever. So plug, and then also differentiate y in terms of dx. So this will be equal to u plus x du over dx. Okay? So, and then isolate for dy. There you go. So now let's plug everything in. Then dy was u dx plus x du. And all of this is equal to 0. Now we're going to do the painful thing of foiling everything out. So let me start. Okay, so this one's first. Then this one. So it's x cubed du. Okay, then this one. So minus, this is going to be x squared u squared dx. And then this one and this one. So it's going to be minus x cubed u du. Okay. And this is the same thing as the following. Oh, wow. Look, these and this cancel each other out. I think that looks like the only thing that actually cancels each other out. So let's collect like terms. Wait, hold on. I think I could just take out the x squared as well. Okay, that looks good. And so it's these two that are like terms, and then these two are also like terms. Okay, so it looks good so far. What I'm gonna do now is divide everything by 1 plus u. So and then also divide everything by x cubed. So this becomes 1 over x dx plus 1 minus u all over 1 plus u du equals 0. Alright, so now look what I just did now. This is in terms of well, this is in terms of x. Sorry, all the x's are being times by dx, all the u's are being times by du. Now we can do separable integration. So I'm gonna bring this to the other side. So it's minus 1 minus u all over 1 plus u. Distribute the minus in. So it becomes uh, u minus 1. Okay? And I'll divide this as u plus 1. Alright? Of du. Now we can integrate both of these. So this becomes ln of x plus c1. This one, I think it's going to be a little tricky to integrate this one. So we have the integration of u minus 1 all over the u plus 1 du. What I'm going to do is add 1 and subtract 1 at the same time. So we're going to put 1 here, then 2 minuses here. Okay, this is still the same thing as this, because this one and this one will just cancel each other out, but I'm not going to cancel them out yet, or at all. I'm going to leave them as it is, and break this fraction up. So this is just minus 2. This and this cancels each other out. So this is equal to the integral of 1 plus, so, or I'll just put minus here, minus 2 u plus 1 du. And that's just x, sorry, that's just u minus 2 ln of u plus 1. Plus c2. Alright. Now, let's see what we should do now. Let's bring all the c's to one side. So, okay. So, I'm going to combine these two and just call it c. Now, the next thing I'm going to do is have everything to the power of e. So, this and this cancels out. So, we just have the absolute value of x equals eu minus 2 ln of u plus 1 plus c. Okay. So, this is the same thing as eu times e minus 2 ln of u plus 1 times ec. Okay, so now what I'm going to do is get rid of this absolute value. So by putting a plus and minus here, I'm going to put ec here. And what I'm going to do is set all of this to be one big constant, c3. Okay, now I'm going to put this minus 2 up here. So that means this and this should cancel each other out. Okay, looks good so far. So now what I'm going to do is do the following. Recall, we said u to be equal to, we said y to be equal to ux. That means u has to be equal to y over x. So we'll plug in that. Okay, looks good so far. Now let's see what we can do. We're gonna have c isolated. So we're gonna divide everything by y of x times y over x plus 1 to the power of minus 2. And same goes for that as well. So this becomes xe minus y over x times y over x plus 1 to the power of 2 equals c3. Okay? And that should conclude to be your final answer.